Hello and welcome to this Formlabs webinar. This is a shortened version of the original broadcast. If you'd like to view the content in full, please click on the link below.
Let's start. Thanks everyone for joining us today. I'm going to talk about how to leverage 3D printing at every stage of product development. Quick presentation about myself. I'm a product application engineer at Formlabs, and I'm conducting research on application for 3D printing in manufacturing and engineering, and presenting the results of my research through white paper and webinars, and other type of technical content. So the agenda for today, the purpose of this webinar is to give an overview of all the different use cases for 3D printing and in what area it can help your business. So hopefully it will be helpful if you are not using 3D printing today and would like to identify some possible use case for your company, but it will also be useful if you're already having 3D printing capabilities and would like to diversify, search for more ways of using the technology and how it can improve other aspects of your business and go a bit further of what you're doing today. So I will give an intro on the benefit of using 3D printing, that it accelerates product development. I also want to give some guidelines on how to choose the right 3D printing technologies and materials. And then I will dive in showing and giving an overview of the different applications with various user stories, also recommendation on materials. Just so you know, we also have some specific content in each of these applications. So we will refer this content if you want to dive deeper into one of those applications. And as I mentioned, we will have a Q&A session at the end. All right, so let's start. First, an intro on the purpose of 3D printing and how it accelerates product development. So I first want to give some context about product development in general, the product development cycle. So there's no one definition of how product development cycle is being done. But if you're developing a physical product today, you might have a lot of different steps. So it takes many steps to bring a product to market. So you might have something similar to this cycle, this process. It starts with ideation, where you define the concept, the business case, and at that step, you will probably want to produce 1 to 3 units of your product, of your physical product, to help you, produce ideas. And then it goes into the engineering development and the design development that usually happens in parallel. And that's the stage where you will want to define specification, technical specification, and do some testing. You will probably need 3 to 10 units to do that. Then you go into validation, which is a phase of intensive testing. This is where you set up engineering prototypes, beta prototypes. You test your product with your beta testers, and you also test your product for setting production lines. So those will be phase where you will want to produce more units, probably up to even 500 units. This is pretty common for market testing and user testing and mechanical testing as well. And finally, you go into production, and this is commercialization, manufacturing, and usually it's in mass production. So you can see that at all those steps, it really helps to produce different units and different iterations of your final product, and this helps creating a better product. So one thing we see is that today most manufacturing methods are actually based on the concept of mass production. So it's basically producing a lot of identical goods in large quantity, and those techniques are pretty expensive, they are standardized, they require expensive tooling, skilled laborers as well, and usually it's rarely cost effective for low volume, and it really allows a little very rarely allows modification in your product along the way. So it's quite challenging to produce low quantity of parts and prototype and iteration of your product with those final mass manufacturing method. In contrast, if you want to do custom manufacturing, this is usually being done in workshops. Traditionally, it's performed manually or with some CNC machinings, and it can be pretty costly. It's usually high cost per part. It's also can take some time, and it's usually restricted to one-offs or very just limited parts. And outsourcing also comes very long, with weeks of lead times and high cost as well. So today, the challenge in manufacturing for whoever who wants to develop a product is that there is not many possibility to produce low volume of parts. This is where 3D printing enters. So we see that most traditional manufacturing subtractive and formative traditional method are not so cost effective for low volume of parts. You can see on this graph, this is the number of parts, this is the cost per part versus the number of parts. And this is where additive manufacturing become interesting because it really enables the production of low quantity of parts. So that's the high level benefit of 3D printing, producing low volume of parts in any kind of way. So why? Because 3D printing is a toolless fabrication process. So it gives flexibility to fabricate low volume of parts and speed. So you can produce that very quickly and cost efficiently as well. And also on the other hand, you can increase design freedom, complexity, and customization. So you can produce custom parts. So custom prototype, you can produce custom tools as well. We'll dive a bit deeper into what are the possibilities. But I just wanted to set this ahead. This is really like the main reason why we see benefit in using 3D printing. All right, so now what are the technology up there and how to choose? So there are actually many different 3D printing additive manufacturing technology. Here's a recap of the three main one, or this also like are different variation for each. You basically have FDM printing, fused deposition modeling, which melts and extrude thermoplastic filaments. This is usually great for entry price and low maintenance, but it also has lowest resolution and accuracy. So it's very popular for early proof of concept models and early prototypes and so on. Then you have all the resin-based technology. In particular, I'm looking into SLA printing, in which a laser cures photopolymer resin. This has very high resolution and accuracy capabilities, so it's great for more functional prototypes, more beautiful parts and patterns and molds as well. And finally, I'm going to look at today SLF's technology, which is selective laser sintering, where laser fuse polymer powders and it produces parts that are very functional, very strong, and usually preferred for industrial application and end-use parts. So those are three main technologies. You can see here the extrusion on the left, the resin-based in the middle from SLA, and the powder from SLS. At Formlabs, we design and manufacture professional 3D printer. We have a core product in SLA with the Form3, Form3L, post-processing units, Form3 Plus, sorry, and post-processing units. And we also have SLS product line with the Fuse 1 Plus 30 watts and also the Fuse Sift. So I'll focus on those two today and explain what you can do with those two technologies, where it is better to use which, and what material to choose as well. So first, SLA, stereolithography. So as I mentioned, it uses a laser to cure a liquid resin that hardened into a plastic. And this technology is very good for clear details, very smooth surface finish. So it really gives a great aspect on the surface of your parts, beautiful parts, and good accuracy as well. So I will always favor SLA when you need to choose to produce beautiful parts. It also, we have desktop printer, we also have benchtop printer, but they are, in general, they are very easy to set up, to operate and maintain. So I would say those are really accessible to have on the desktop in your office or in your lab, in your prototyping lab, and they are very easy to integrate and learn how to use. In SLA at Formlabs, we have a really broad range of materials. So that will be like maybe the second best, how do you say, like point of interest. We have library that propose general purpose materials that are in our entry price resin. And then we also have a lot of engineering resin. I'll show you a lot of different use cases for that, but this really can enable multiple applications and help you prototype parts that are functionals and also do functional and use part as well. And then we have medical resin and dental material that have biocompatibility certification. And then we have specialty material as well for jewelry, for example. So that was for SLA. Now I will talk about SLS. So while SLA is resin-based, SLS is powder-based. So it's use a laser to fuse powder together, to fuse powder particle. And one of the great aspects of SLS is that while the part is being shaped, it is actually holding on the powder bed. So you actually don't need to use any support when you print, while you need to use support with SLA. So this technology is really great for producing very complex parts, complex shape. It is also the preferred technology for industrial application in general because it has very high throughput. You have a very big volume. You can produce a large volume of parts. So you can really scale production volume with the SLS. Yeah, in terms of complex shape, as I mentioned, you don't need to have support. So you can see it here, you can really stock all different parts in one build volume. You can produce intricate shapes such as interlocal links or functional assemblies or leading hinge. Those are all type of geometries that are popular. But the main advantage of SLS is really the materials. The materials are SLS powder are really popular in industry standard, like industry standard material. They are strong and they are adapted for end-use parts. So they are suitable for end-use parts. We have at Formlabs a portfolio of different nylon powders. So those are true nylon that have been fused with this laser, and we have a range of different nylon. So those are your common nylon that you will be using with injection molding. First, we have nylon 11 carbon fiber. We have nylon 12 glass field, nylon 12 and nylon 11. Those are all different material properties. So in general, I would recommend going for nylon 12 if you don't really know what powder to choose. Nylon 12 is our general purpose powder. It has very high detail and great dimensional accuracy. It's strong, and it really holds very well for end-use applications. Nylon 11 will be more ductile, for more flexible parts, so application where durability and performance are key. Those are great choice. And then if you want to go into more specific use case, nylon 11 carbon fiber will be really good for strong and lightweight parts. And nylon 12 glass fields is really good for structural rigidity and thermal stability as well. And recently we also released a TPU 90A powder that is elastomer, SLS elastomer, and very resilient and also skin safe product. So this I think also is a great solution for a lot of different applications. Has really high elongation at break, very good tear strength as well.
Thank you for tuning in to this webinar preview from Formlabs. To view the content in full, please click on the link below. Alternatively, if you'd like to get more information on our products and services, then please visit our website.